This is lesson 48. Take a moment. You're watching this because you wanted to review or you missed a lesson. So go ahead, pause me, try it out, or you can just follow along as I go over it. Sketch and answer. Find the area of the rectangle using the formula area equals base times height. Write the area in a standard simplified form. So area is base times height, and so our base is 7 times x squared times x to the fifth times y times 2 x to the third y squared. So what was the rule? I usually invite somebody up. The rule is when you're multiplying, we're trying to write a monomial in standard form or simplified form, you multiply any coefficients and then any of the bases. If you have like bases and you're multiplying, you can add the exponents. 2, 5, so we get 10. And then like bases, y and y squared, y to the third. There we go. 14x to the 10th, y to the third. All right, inside your notebooks, if you're taking notes because you missed class, always nice to have notes, especially if I happen to do, allow you to have your notebooks out on a quiz or something. This is chapter 6, lesson 3. And talk a little bit more about exponents and polynomials. Okay, we've talked about polynomial, we've talked about monomial. We are going to talk about other types of polynomials. We have something called a binomial, which I want you to add in notes. Binomial, which is the sum of two monomials, right? Bi as in two things, bicycle, bicentennial, bisexual. It all means two, right? So the sum of two monomials. Trinomial is the sum of, any guesses now? Yep, 3 monomials. That's it. And we're going to see binomial and trinomial throughout the rest of the year. So it's important that we kind of hear those words and say it. So repeat after me. Binomial. Perfect. And then trinomial. Boom. Awesome. Okay. We've been using distributive property this year. And just kind of want you to do the distributive property. I want to kind of connect it to what we've been doing recently. So if we're going to do negative 4 times x plus 2, well, you do negative 4 times x and negative 4 times 2. So negative 4 times x, you can write as negative 4x. And then plus negative 4 times 2 is negative 8. So we could have even written it like so. Cool. And that's the kind of distributing we've been doing. Now we're going to kind of ramp it up just slightly. We're going to make the things inside the parentheses a little bit more complicated and kind of apply our rules of monomials, right? So the cool thing is it works the same way up here. You just got to stay more organized. We're going to do negative 4xy times 3x and negative 4xy times 2y to the third, or minus 2y to the third. So what we're going to do is to practice multiplying a monomial by binomials, which is up here, but just a little bit more complex. And so some things you may want to do is just write out your steps. We have negative 4xy times 3x, right? And then I'm going to say this is plus negative 2y here. So I can make sure that I remember plus, again, negative 4xy times negative 2y to the third. But now we can do some simplification, right? We can do negative 4xy times 3x because we know how to do this. We talked about it the last couple of days. Multiply the coefficients. Any like bases, add the exponents. Again, multiply the coefficients. And if you're multiplying by the same base, you can add the exponents. And there we go. We did the distributive property. Students always ask, can I go a little further? And I would say, can you go further here? The answer is no. So we're going to just pause right here and just kind of practice multiplying, following our rules of exponents that we've learned so far. Okay. All right, here's one for you to try. Now we're going to multiply this by a trinomial. So it's going to be negative 4xy squared times this, then times this, and then times this. And if you want to use a shortcut, go for it. I'm going to keep going and make sure we use our rule, right? All right, so we're applying our rules of powers and exponents with distributive property. So the first part of this lesson is to just use a distributive property to multiply each problem. I return and work in groups. Let me come back and talk a little bit more, but why don't you pause, keep going. I'm going to start sharing the answers, and I'm going to do it in my head, but you can feel free to pause, and this document is in your Google Classroom. All right, I just went over the answers so you can pause and maybe look at them. Again, notice that all I was doing was a distributive property. I didn't try to do any simplifying because we haven't talked to it yet. We're just doing distributing monomial times binomials or trinomials, okay? If you're stuck on one, you can always hit me in the comments or ask me in class, but there you go. That was the first part of lesson 48. Okay, we're just going to begin. We've been multiplying monomials by monomials, right? And we just did with the distributive property. Right now we have to also talk about dividing, right? The opposite of multiplying. All right, so we're just kind of thinking, we'll get deeper into it and like write a rule, I think, Maybe by the end, but definitely by tomorrow we'll have a way. So this is you kind of taking a guess. What do you think x to the 8th divided by x to the 2nd is? A lot of students say x to the 4th, right? And that's a great answer. If you said x to the 4th, that's awesome. But unfortunately, it's wrong. What? It's wrong? I know, it's wrong. It's weird. Exponents work a little different. We might find better luck if you think of division just slightly different. Division is the same thing. Another way to write division is a fraction, right? So if I write this as x to the 8th over x squared, maybe you're saying, well, that will still be x to the 4th, Mr. Moran. And I would say that's still wrong. Because exponents are kind of like a shortcut, right? We've talked about a shortcut. So I'm going to write it out in expanded form, and let's see if we can figure this out. 4, 5, 6, 7, 8. So what would x times 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 x divided by x times x equal? And here's where someone says, oh, it's x to the 6th. I'm like, yeah, and here's the thing. It is equal to x to the 6th. This and this equal that. Well, just how, Mr. Moran? Well, and then I offer someone to explain it. And then someone said, anything divided by itself other than 0 is 1. So x divided by x is 1. And x divided by x is 1. So you can see that 2 of the x's cancel out, and you're left with 1, 2, 3, 4, 5, 6 x to the 6th on top over 1. So we've got it. It's right. And maybe you're picturing a rule in your head, right? But let's just make sure that this holds up when we have more complicated things. So we're going to write this out in expanded form. 9, remember, is 3 times 3. G to the 8th is 8 g's multiplied together. 1, 2, 3, 4, 5, 6, 7, 8, right? Over 3 is 3 times g times g times g times g. All right. Okay, but what if we wanted to know what 9g to the 8th divided by 3g to the 5th? Well, is there anything we can divide out? Well, yeah. 3 divided by 3 is 1. Is there anything else that we can divide out? Well, someone might be like, yeah, there's this, 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 and this. And I would say, great. Yep, those are all 1s. So 1 times 3 times g times g times g is g to the 3rd. 1 times 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 1 is 1. So 9g to the 8th divided by 3g to the 5th is 3g to the 3rd. So does it hold up, right? 9 divided by 3 is 3, and g to the 8th part divided by g to the 5th ends up with g to the 3rd. So maybe there's a rule there that we can kind of like find and think about. Let's try one more, make sure we're like, does this keep holding up, and so, because otherwise writing out this expanded form will get really annoying really fast. All right, 2 is 2 times g, 15 g's. It's 5. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Over 8, remember prime factorization, 2 times 2 times 2. 6, 7, 8, 9, 10, 12, 13. This is going to get hella hectic, but let's see. well, 13 here, 15 here, that would just leave 2 g's on top, right? Everything else becomes 1. And then we get here, so this would be g squared over, it's really a 1. So 1g squared over 2 times 2 is 4. Yeah, could we have gotten this without doing all the expanded form out? You might say, yeah, Mr. Moran, 15 and 13, g to the second, and 2 over 8 is, it's interesting. Are we subtracting 2 and 8? No, we're sort of simplifying the fraction part, right? In both cases. So, you are right if you had a feeling. There is a rule for dividing powers, right? So, if you're dividing powers with the same base, what can we do? This will help us with an example. What do we do? You can't just say subtract. What do we say? What do we do with the coefficients? How about we simplify the coefficients using division, right? Or divide the coefficients. Then, right, we're going to subtract. We're going to be specific. Subtract the numerator exponent by the denominator exponent and keep the base the same. Oof. All right, let's see if it works. So coefficients, we're going to simplify using division. So 6 over 2 is the same. We're going to do the division there, right? 6 over 2 times, keep the base the same, numerator exponent minus denominator exponent. So 6 over 2 is the same as 3 over 1 times g to the 8 minus 5 is 3. So we get 3g to the third over 1, or just 3g to the third. All right, let's see if we can do this one. We'll apply our new rule. Simplify the coefficient part, 10 over 2 times, if we're dividing by the same base, keep the base the same, numerator exponent minus denominator exponent. 2/10 is equal to 1/5 times g to the 12 minus 3 is 9. And then we just need to know what's 1/5 times g to the 9th. Well, that's 1g to the 9th over 5, which is g to the 9th over 5. Great. So, let's try this. Mr. Moran, this one's, no, is it? All right, let's try to, you can do it the long way you can't. So, we're going to do 8 divided by 2 times, we're dividing by the same base, g, numerator exponent minus denominator exponent. 8 divided by 2 is 4. And what do we get? Well, what's 2 minus 5? -3. You nailed it. Mr. Moran, there's negative exponents. Yes, there are. We'll get into it. But for now, we're just following our rule. Okay. Another one. Now we might have multiple bases with exponents. We just got to make sure we follow the rules. So we're going to keep, well, technically it's 1 and 1, but we don't need to. So we have 8 to the third, 3 minus 2, times g to the 12 minus 3. A to the 3 minus 2 is 8 to the 1st. G to the 12 minus 3, G to the 9th. So we have A, G to the 9th. One more, then I'm going to set you off to practice a little bit. So go ahead. Let's see how you do this one. Pause me. See if you can figure it out. I'm going to get going on it. So we have A's. Okay, I'm just following the rule. Keep the base the same, subtract the exponents. Numerator minus denominator. So we get A to the negative 6th, B to the 0, and C to the 6th. Boom. Awesome. Nailed it. So I want to give you some time to practice. I think I have you finish this for homework. Let's see. Oh, yeah, I have some of this. So go ahead. Let's apply our rules for dividing. I'm going to write the answers down. I can do them pretty fast in my head. I'm not going to show all the steps, but pause. Unless you just want the answers. Keep the base the same. Subtract the exponents. Keep the base the same. Subtract the exponents. Keep the base the same. Extract the exponents. All right, so those are the answers to the classwork. Maybe they were to finish for homework. I'm not sure. I'll see you all